So the first session this morning is Advanced Diagnostics. It'll be your instructor today will be Keith Donaldson, who you met earlier. So take it away, Keith.
Excellent. Thank you very much. So we're going to have a look at advanced diagnostic tools here. This might get quite technical because we're going to show you a tool of our debugging tools and analysis tools that we use ourselves to try and identify problems. So one of the things is this isn't going to be about solving problems in your plant, because we don't know what your plant is or your process is necessarily, but it's how we work and use VTScada to diagnose problems. And we'll cover off topics such as gathering diagnostics for contacting our technical support and what sort of information we're looking for from you to try and help you diagnose your problems and why we're looking at that. It'll give you an idea at the low level behind the scenes really of how VTScada works. So hopefully if you're not following the technical component of it, you'll get at least some appreciation about what the product's doing and how it operates. I've got a sample little setup here. We're going to be jumping in and out of PowerPoint. This is a practical show and tell. Some of the fonts, I guess, might be quite small at the back, so I'll talk through everything so you don't miss. We are recording the session as well, so you'll be able to follow this along. But what I've got set up here is my notebook, which is KDNB, Keith Donaldson notebook. And then I'm also running a virtual machine on the same machine called Keith KDNB VM, virtual machine. Both of them are running VTScada 11.3 something very late. And just to talk about that, internally we all run the very, very latest build of VTScada. We want to get as much time testing and operating and working on it. So this is a build that I got from Glenn yesterday. So it's got everything in it. So if it goes wrong, we're running a live system. You'll forgive me, but it should be fine. There are a number of applications that ship with VTScada, and probably the single biggest one that we use all the time for diagnosing problems is the source debugger. The source debugger is an application that allows you to peer behind, look at the source code, look at the variables, and so on. So I'm going to give you a guided tour of the source debugger and some of the features that we use on a sort of daily basis. Right, so I go to my running application. Just to again give you some background, I've got a Modbus simulator just running in the background here. It's got 6 registers, and if I change the value of a register, hopefully you'll see the value change. So I changed the first register there and the top register changed. That's great. I should also be able to show you the virtual machine running here, which is running an identical synchronized copy of the application, and both are potential servers. And that's important. We'll come back to that slightly later on. So in the application manager, which I should be able to find somewhere hidden behind all these windows, there we go. We have the source debugger, and you run it like any other application. And this is the source debugger, and it's got a number of features. We can have a look at the first live summary, which gives us a brief overview of what operating system is running. And again, that's really important because we're oftentimes remoting into a system, so it gives you an idea of the fact I'm running Windows version 10 64-bit with 8 CPUs, so giving us some clue into the system. I can also have a look at the VTScada info here, so you can see I'm running what is reported as 11.3.99.01, which is an automated build, so it's not actually going to be a release. Serial number 1. Yeah. And then it gives us some idea of the license type. So I've got full, when it expires, number of tags allowed, number of internet clients, and the memory used. So just a brief summary there of what the license key that's running this particular application. Below it, you can see a list of applications that are currently running. So we've got the system library, which is the VTScada itself. we've got the source debugger itself, so you can actually use the source debugger to debug the source debugger. It gets a bit recursive. So, and then we've got the Advanced Diagnostics application. I'm going to click on the Advanced Diagnostics application, and you can see that the windows at the side here have populated. And what this is showing here at the moment is a list of all of the code modules that are running in this particular application. Now, you don't need to have the source code installed in the machine to see this. This is all coming from runtime information on this particular license. And you can see that there's quite a lot of modules running. Below, you can see what is a list of the variables. So I'm just going to pick, I'll cover off another topic actually here. I'm going to drill down, I want to examine the code that's in the page, this page here. And the easiest way to do that is by using this little pick tool up the top. So I click once on that, I click into the VTScada window I want to debug, and you'll see that it's automatically taken me down to, just making sure this is following along, the graphics module. Now I'm not sure you guys back, you're probably struggling to see that. Is that true? Okay, so we've navigated down the tree, it's automatically jumped into the graphics module that is running the whole of this page. And I'm going to drill down further into that. Within the graphics module, we have a variable called page, and it's set to the overview. I just click that, and I'm now looking at the actual code for the page. The code is actually shown in this window here. So I don't know if some of you will be familiar with VTScada script, but you'll see I've got a number of GUI transformations, GUI texts. These are all the widget objects that have been dropped on the page to create it. And we're able to interact with them by looking at the variables down on this left-hand side here. So we can see things like which bitmap we're displaying in the background, the color overrides, and a few other variables that I've added in there. Now you'll see there are 4 tabs along the bottom. We've got local, instance, auto, and global. And just to run over briefly what they do, local just shows all the variables that are listed locally in my page. I'm able to inspect them. However, if I click on the auto tab, it goes blank. And what that's looking for is for me to select a line of code. So I'm just going to click somewhere in here. And what it does is it scopes around the line of code, finding all of the variables that are used in the closest vicinity, and lists them all straight there in the window for you. So I use that quite a lot, certainly just to narrow down what would typically be a large list of variables to try and hone in very, very quickly. Global, what that does is it walks up the tree of modules. So you can see here we've got this tree. I've got the overview, and then it's in, I guess I'll click on the scope tab here, which will show you where the module is actually running, and it will show you a list of all the variables that module can see in VTScada. So that would typically be things like your settings, your configuration settings. So if you're wanting to try and access a variable from a page configuration setting, you can go in and you can scope up this tree and see them. The third tab, just whilst we're on these trees here, so we've got the static tree. The static tree is how the code appears as it's written. So the first module declared in the code will be the first module shown in the static tree. The second tab is the scope tree, and this shows the calls. So if one module calls a second module, you'll see it organized in that hierarchy. And then the, sorry, that's the, I made a slight error there. That is the call tree, that's the third tree. That is, as the name suggests, the call hierarchy. When one module calls a second module, it's listed in that hierarchy. The scope is who owns the particular module. and that's where the module is declared. So these are fairly technical things. Some of you who've done the advanced courses that will make sense. We've just briefly touched on that, but it gives you some idea of what the source debugger is. It allows you to navigate around your code and see particular variables, see the code, and inspect those things. If I just nip back to the presentation here, see what else we wanted to show. We have breakpoints. Now, I put a warning there. What a breakpoint does, it allows us to stop the execution of VTScada and hold everything. So all processing stops. Allows you, we can then navigate in the source debugger and have a look at all the variables and see exactly what's going on, what the value of certain variables are, what state the system's in, and so on. But by its very nature, stopping the execution of VTScada is pretty dangerous, especially in a live production event. If you'd like to know how I find out the hardware, speak to me at Howl at the Moon tonight, and I'll tell you about a story when I was stuck offshore on a North Sea oil platform, having shut down the production on that platform. So use with real caution. The breakpoints are incredibly useful though. If we're working, trying to figure out why something is going wrong, we can actually stop the execution of the code and then step through and see each line execute one at a time. So we'll do that just now. I've got just a little while loop here. I'm going to place a breakpoint. To place a breakpoint, we go up and use the breakpoint icon at the very top of the screen. It's a black circle for those that can't see at the back. And when I do that, you'll see a little orange circle appear at the side. So that's the breakpoint pressed, set, I should say. So if I now return to my application and click on this button, if one, you'll see that immediately the source debugger comes to the front and a little yellow arrow appears in the breakpoint. That's indicating we've hit that breakpoint and execution of the entire system is now halted. That's not quite true. Execution of the thread that the system is running is halted. And VTScada runs in a multi-threaded environment. We actually have threading built into the product. Threading just allows multiple pieces of code to run concurrently. So whilst we're kind of stopped on there, we can look around and see the variables. So you can say, I set a variable there, k equals 100. You guys won't see that at the back. And you can see that the variable k listed there is indeed set to 100. I can go and change that. I don't want it to be 100, actually, I want it to be 50. So the value of k is now set to 50. When I release the execution, it will now go on and run 50 times instead of the 100 times it was originally set to. So you can actually go in and alter the state of the entire system in real time, whilst time is frozen, I guess. There. So we can also do single stepping. So if I just, these are the icons at the top in the middle of the toolbar there. If I just click on step over here, you'll see the line of code execution jumps on one. And what I'll do, if I just set the auto window down here, which is typically how it would look, you can now see the three variables that are in play, A, B, and K. Both are set to 0 at the moment. And then we're going to jump into a subroutine. I'm stepping over these subroutines, and then it decrements K. So K is now set to 49 and runs through the while loop. I'm just going to let that run. And then it stopped again. Okay, it's now hit the next breakpoint. And the reason for that is the condition that I've placed the breakpoint on has come true. It means so we can set the breakpoint on any particular line of code, and as soon as the line of code is executed by VTScada, it will hit the breakpoint and stop. We'll come back to breakpoints just once we've discussed another couple of topics. The very handy icon there, the second one in, it's a sort of half black, half white circle, allows you to disable a breakpoint but leave it in place. And when you're developing code and jumping through the source debugger, just checking how things are working, it's a really neat way of keeping a bookmark on your code. You can place a breakpoint, disable it, and then when you click on the breakpoint, it'll automatically jump to that line of code. So if I place a breakpoint somewhere up the top of this module, for example, just on any sort of arbitrary line, so as I click on the breakpoint, it'll actually jump down to the line of code that the breakpoint's on. Which one am I? So you have to double click on those. Right, I'm just going to get rid of all those and return the system. Sorry, I keep losing my mouse here. Click that button again to stop. Stop it. Right, back at the source debugger. Again, back onto the summary window. We've got some more utilities which are useful. The modules returns a list of all the modules that are running in VTScada and the count of the modules. Now, this is really handy for finding memory leaks. It's one thing that I find it most useful for. If you're writing an expression, for example, or a custom piece of code or a page, and you inadvertently end up starting lots of modules and not stopping them, what you'll find is that over time your memory starts increasing until you hit the process limit around 2 gigs, or you can set it to 3, and then VTScada will crash. It just out of process memory, and that's obviously a problem. So periodically, it is very much worth coming in and looking at the module tree and just having a look at the counts over time, making sure. So you can see we've got the biggest count is menu items in a blank VTScada application. That is all the menu item tags that you see in the default VTScada install. If you look in the tag browser, that's all your menu tree and all the palettes for all the widgets that you have. Okay. That's really all I want to say. It gives you a little summary there. Currently on a pretty plain application, 11,233 modules, of which there are 7,480 instances running at this point in time. So the next one, threads. Again, just briefly touch on this. We touched on threads in the source debugger, and I mentioned that VTScada has multiple threads running. What this window here shows you is the threads that are running in the system. So you can see there's all sorts of system threads there. We actually have one thread started for every application that is listed in the application manager. Most of them are sitting doing nothing at all. What they're looking for there is for the user to come along and do any import of data or synchronization. So I can demonstrate the threads just on that page there. I put a button that starts a thread. So if let me see if I can split the window a little bit and show you. So currently we have 28 threads running. If I click my thread button, we now have 29. And I should be able to see my thread. It's probably, where is it? I can't even remember what I called it now. It's somewhere in there. Let me just start a few more. It'll become obvious. Let me just update. There we go. So I clicked this little refresh icon that you can see, this paper refresh. And what that does is a live update of this list, so it's now going to continually update, so you can see the threads running in real time. And you can see my threads here, my thread 0, 1, 2, 3, 4. and then I had a button to kill the threads, and if I press that, it kills them off one by one. And kill the last one. There it goes. So I'm going to use the threads to demonstrate one of the other, I guess, real important subjects in breakpoints, which is something called a conditional breakpoint. And that's really helpful when you're trying to debug, let's say, a tag, and you've got 10,000 of them instantiated in your system, and you want to debug one of them. How do you get quickly to that one without paging through 10,000 instances of it? So what I'm going to do here, I'm going to launch off some threads. I'll go to the code for the thread, which is just in my page. If you just bear with me one moment. And in here we've got my thread module. And you can see I've got 4 instances running. The instance count just at the top of this window over here. In here. And in each of those you can see there is a variable I that is just ramping up, just to give us something to work on. If I place a breakpoint, let me just maximize this window. If I place a breakpoint just on that I incrementing, on the line of code that's incrementing, what you can see is we've hit the breakpoint 4 times, once on every thread. So all 4 threads have stopped executing. But that doesn't really help, because I wanted to breakpoint on just one. I'm only interested in the one. So what I'm going to do is I'm just going to disable that breakpoint. I'll let them go. And then I'm going to click on this question mark icon that you can see up top. And in there I can set that to be what we call a conditional breakpoint. And that pops up, again, some of you in the back might struggle here, but there's an edit field at the bottom of this window. And that allows us to specify an expression that will be, when true, will trigger that breakpoint. So for those of you familiar with writing expressions in VTScadaScript, it's exactly the same. And I've got a thread ID variable. You can see it's different on each thread, currently 6, 7, 8, and 9. So I'm going to set the conditional breakpoint to be thread ID equal 7, for example. Click OK, and then enable that breakpoint. And you can see that it's done exactly what we'd hoped it would do. It's stopped on the breakpoint, and you can see that it's thread ID number 7 over here, and it's frozen. We can have a look at the other threads, and you'll see that they are still indeed executing the counter incrementing. So that's really, really useful. Things like you can do \name equals and set it to the name of the tag, so you can find the name of a tag in a huge list, for example. It's really very useful for trying to nail down that one particular problem module that you have in trying to find it. Right. I should have pointed out just before I did that, but the breakpoint has a little question mark symbol in it when it becomes a conditional breakpoint. So you can identify that differently from a standard breakpoint. Right. Moving on. I'm going to cover off a topic that some of you may have already encountered. It's called dump files. What happens when VTScada crashes? It doesn't happen very often, and when it does, we're very, very interested. We want to know. It should never crash. That is our nirvana, and if it does, we really want to know about it. But built into Windows is a debugging system that will take the in-process memory image of VTScada and dumps it out to a file. Additionally, we can actually cause that to happen. So we can take VTScada as it's running on your system and generate one of these dump files. Now they're quite large. They're exactly the same size on the disk as the image is in memory, for obvious reasons. It's taken the whole image and dropped it out. But they do compress very well. And if we get that image, then we're able to load that into the source debugger, and we can see the exact state of your system as it was when the dump was generated. And we can see the last, now don't quote me on this, but I think it's 10,000 executions that have occurred on each of the threads on that system. So if something is going wrong, we've then got a fair idea about what's going on. Typically we ask for these when there's a problem that we can't recreate in the office, and we want to be able to see the state of the system so that we can analyze and try and identify what it is. But I'm going to show you how to generate these dump files, and it's very, very straightforward. I'll show you the three different methods. The first one is right here from the source debugger. Up on the menu up top here, you can see there's an open dump file and there's a create dump file. Now again, I'm going to warn, creating a dump file will freeze the entire process for the duration of the time that it takes to dump the file out to disk. It's not very long in modern systems, but it can be tens of seconds. In that time, if you're running on a redundant server, the redundant server will have detected a failure of the primary and will change over. It will stop all communications. So if you're in the middle of communications with an RT device, or you're in a call to a PSTN modem, or you're doing radio communications, you've got internet client connected to that machine, it's all going to halt for the duration that the dump file is being generated. So just use a little bit of caution. But it's an incredible tool which we use very, very frequently. So any of you that have spoken to Doug and Jen and support, and you've been having problems and not been able to narrow down the problem, we will ask for one of these dump files. So to generate it from the source debugger, click the create dump file. You can see here I've been working on that yesterday. So you just give it a name. We'll just do session 1, click save, and whilst the cursor, that's it, it's saved it already. So it's nice and quick, not a particularly big application. When we're dealing with systems that have 1.5 million IO, it takes a lot longer. So that is it, and I can't actually remember where that parked it. Was it in my temp directory? So you can see that that particular image was well, three quarters of a gig in size, so 726 meg. So reasonable size of file, but they do compress down. We would look to get those through our FTP site, ftp.trihedral.com. It's an anonymous login, and you can upload those to their in the incoming directory. Nobody else can download that, so the site is secure for uploading those dumps. And typically, you'll be guided by Doug or Jen or tech support there on the need for those. But it's incredibly useful. So what I can do now that I've generated that crash dump is I can actually go and open it and inspect it. So if I take the session 1 dump and just click open, you can see it loads the files, and in a moment you can see now a new tab has appeared. So summary dump. It's a very glamorous name. And again, you're presented with the same thing, so we can actually go and take a look, and it'll show us the modules that were running at the time we took the crash dump. So I should say, I call it a crash dump. Invariably it gets called a crash dump because it was originally generated from, some of you will remember Dr. Watson, the little application that used to run under Windows NT and so on. It was actually broken. Steve, our developer in the Aberdeen office, rewrote it for Microsoft because the files they were writing were actually corrupt. And we used to have to ship a version with VTScada, but that's all in the past. So you can see that we can look at the modules there. I can open up the thread list and I can see how many threads were running at the time. So you can see there my thread running in the main state in statement 0. So it's kind of neat. And then you can actually click through each of the modules and see. So this is this is running on my. I need to go into the summary page, but I should be able to click through and see. Why am I seeing the live thing here? Because I haven't clicked on the application. Just give me 1 second. I need to click here, and that's going to load up in a new window. So now I need to find my overview page, which should be under overview. Click into it, and my thread modules, and you can see it's all frozen in time. Nothing's live or updating because it's running from the dump file. But you can see the value, for example, of I at that particular time. So if you take it from a live SCADA system, you're able to actually go in and see the value of the variables of the data acquisition on any of the pages. You can see the state of any drivers, any communication statistics. Internally, we can see lots of information. So it's a really very, very useful diagnostic tool, all based on the premise that you need to actually be able to take the dump file. Okay, I will quickly touch on the two other methods that you can use to take a dump file, especially if you're having to deal with an end user. If you run up the task manager in Windows, you can see all the different tasks that are currently running there. The VTScada task at the top. If I just right click on that, there's a create dump file option there. So this isn't specific to VTScada. You can take a process dump of any particular application. The fact is that we now know the format of the file and are able to interrogate that, load that back into the source debugger is the clever part. So that, by default, stores it in the app data path. So if you run up an Explorer window, just stick %app data in there. It takes you to the roaming profile, so you just need to go back one directory in local, and you'll find in the temp directory, I believe it is, and it's called VTS. So you can see I already had a VTS dump file in there, so it's just added a second version of that. And that allows you to grab those files as well. So it's potentially an easier way to create a dump, but it's more hassle explaining to the customer where you have to go to get it, to zip it, to download it. The third option is we actually ship a tool. Let me just see. In the VTScada, we'll go there, dump tools directory. And you can see there's a program in there called User Dump. It's a Microsoft program. And you have to specify the process ID of the VTS.exe process that's running. So it's a little bit more onerous to actually go and create the dump file. It's there. Some of you command line users who prefer using command line will love that, but otherwise it's probably easier doing it through the source debugger or the task manager. Okay, that covers that. Let's have a look and see. Dump files there. So I've warned you. I say it's often called a crash dump. It was just because of Dr. Watson's there. User dump, right-clicking on the VTS process in Task Manager, or creating the dump file from the source. So, right. So I showed you the thread window in the source debugger. To show you the execution history, because it's kind of interesting, especially on the dump file. So we can go back to execution history, and I'll pop this open into its own window. this little blue icon with the title bar allows you to pop these open into a window on its own. So what this is doing, this can show us the last 10,000, 100,000 or a million execution history. So we can actually walk through the code and see the order in which VTScada processed the statements. Now, for those of you who have done the advanced course, the scripting courses, you'll know that we teach typically that you don't know the order in which we're going to execute statements because VTScada is entirely event-driven. And that is essentially true. But what you're peering into here is the actual ordered list of things, the way things happen. And at times, you do need to understand that. There is obviously a process execution. So you can filter this. I can just have a look at my thread 6. So that was one of the little threads I launched off there. Update the filter. And you can see it's, again, something at the back, I apologize. You can see it's just running between two statements, statement 0 and statement 2. Now, the way these statement numbers, I guess it's worth touching on that. The way that we deal with that, every statement within VTScada is given a number. So we're able to identify exactly which point. And there's a real cheat method of figuring out what they are. The numbering scheme, you'd have to quiz Glenn on why he came up with this scheme because it's somewhat bizarre. But if I go to my thread module, if I place a breakpoint, I can't do it on a dump file, so I'll have to do it in the live system. Excuse me, till I zip back to live system, and there, if I place a breakpoint, it actually shows you the statement numbering on the last line of the breakpoint there. So that's statement 3. If I place a breakpoint on the next one, I imagine it's statement 4. And the way that numbering works, just to give you a quick insight, is it starts at 0, it runs through all the steady state statements, for those of you who understand the difference between steady state and script statements, and then it goes to the first script and numbers all the ones in the first script, then it goes to the second script, numbers all the ones in the second script. So it's a bit of a jumpy numbering system. Anyway, moving swiftly on. Yeah, so we'll just finish off on the execution history there. You can see you're able to list the threads. We can have a look at the main VTScada thread. Really wasn't doing very much at all. Doing something called get session ID. I'm not familiar with what that particular module does. And there are various different things here. So you can see auto flush that is doing queues, so that's inter-machine communication and all sorts of stuff going on there. So the system can be really quite busy. There's quite a lot going on. Yeah?
Can you search for breakpoints?
Can you search for breakpoints? No. The only thing you can do is look, the breakpoints are only visible in the breakpoint window. So all breakpoints are listed down in this window here. And they're only active when the source debugger is open. As soon as you close the source debugger, and sometimes you'll see a warning. If I put a breakpoint on there and close the source debugger, it'll actually pop up a warning that says, sure, you want to end this session. You've got active breakpoints, you might want to deal with those. In fact, something that I haven't planned to cover off on here, but you can actually save the workspace of the source debugger, so that if you're set up with lots of breakpoints and lots of modules and you're intricately working on either debugging or developing a piece of code, you can save your workspace with all those breakpoints and then restart and come back into the system. So, yeah, execution history, I think that's really all I wanted to cover off on that topic. So the high resolution profiler. Now this is something that is not released yet. So this is coming to a VTScada installation near you. I'll pop it open in its new window. So the profiler, we've always had a profiler available, though it was somewhat limited in its capabilities. and the results that it produced were not 100% accurate. They were close enough that allowed you to zoom in on particular problems, but didn't give you the perfect ideal path to finding the problem. So a lot of work has been done on producing this high resolution profiler. So the profiler allows us to run the application and determine how much time each bit of code is taking to execute. So, for example, I'm just going to start my little if1 thing. I'm going to kill off all the threads, make life a little bit easier, and run if1. So, if1, you'll hear us talking about this quite a lot. The way that VTScada works, again, those that have done the training courses will have either inadvertently or deliberately created an if1 situation. But because it's event-driven execution, if you have a statement that is always true, it will always execute. So if you have if true, it's always going to execute, and that will burn through your processing time. So I've actually written this to do that. And usually the first clue that something's going wrong is if you take a look in the task manager. You can see at the moment VTScada is taking 18.6, 19.9% of the processing time. You think, well, 20%. But actually, the task manager shows the performance per core. So if we actually have a look, you can see one of the cores there is really screaming. Very high processing load. And I'm sometimes gobsmacked at the number of installations I've gone out to where the system is running in that state, where they've got an inadvertent condition that's causing the system to loop continually. And it degrades performance across the whole thing. So you'll notice dragging windows are slower. If you're creating in the Idea Studio, things start to slow down. Just everything comms, you can start getting comms dropouts and so on. So the profiler is a tool that helps you hone in on that. I'm going to just run the profile here. So there's a play button up in the toolbar. Just hit play. And it's going to run the profile. I'm going to run it for about 5 seconds or so. And then just hit stop. And what we get is, again, I apologize to the folks at the back here for the text being quite small, but we get a list, and it's ordered. It gives us a list of counts of things that are happening and the time it took to execute those things. So we can have a look and see at the top, the total time is probably the biggest giveaway here. We can see a large number of counts and a large time slice. And if we expand that out, it gives us a list of exactly what was going on. And again, the counts are small, but the amount of time it took to execute those counts is very, very high. So that gives us an indication that there's something not quite right going on here. And if we drill down again, we can actually start to see the different sections, and suddenly the number of counts and the time. This particular module here seems bad, and if we go down, who knew the module name's called busy subroutine, might be a bit of a giveaway, but it allows us to see that we were able to just drill down this tree, and suddenly we get down to the actual call, and we see that there were 4 million or 41 million executions of that particular line of code. That, I think, is probably our problem. And what's kind of neat is that you can click on this hyperlink here, and the source debugger, which is off in the background here, will actually take you to the line of code that's causing the problem. And not surprisingly, I've got a 100,000 counts in a while loop in a script, which is being called repeatedly from another script from another while loop, just to demonstrate the problem. But it allows you to hone in. I did that the long way round. The guys having to work through the tree of calls, seeing where things are going, isn't particularly intuitive, but they've put a really nice button at the top here that allows you to flip the whole thing on its head. And you're looking at this profile tree now from the bottom. What is causing the problems, and then the call tree up to it, and immediately you can see a massive count there. That should be a big indicator that something wrong. You can drill straight into that piece of code. So this allows you, the old profiler didn't allow you to see into scripts. It would just tell you that the script trigger condition was causing the problem, but the script code could be huge. You could have 100 lines of script in there, and you still don't know exactly where the problem is. Now you can actually get down. The values that are reported are much more accurate, and it takes into account some things, some complex things like the semaphore lock in VTScada. And these are operations that hold up the rest of the script code processing. So you can actually identify and see exactly what's going on in there. So I'm not going to say too much more on the profiler, just that it's there. It's complex. Yes, sorry.
I noticed you have a return value invalid there. What's that indicating?
The return value, just that I'm not actually returning a value at all from that module.
So it's not ever leaving that subroutine?
Correct. Yeah. So, or more strictly, that the value that is being returned has not been set. So I could still return from the subroutine. I could return invalid. I can run over that. If you want to see me in the developer, Dan, I'll be happy to run through a wee example with you and show what that is. So just very briefly, you can also, in the new profiler, you can set up the profiler to run for a contiguous period of time and export the data, either as a CSV file or a .profile. A .profile file allows you to load the results back into the profiler and examine them using our interface. The CSV file allows us to export and load into Excel or any other text editor and see the values that are listed there. It means that you can baseline, so you can run the profile against your application as it's running now, make some changes, run it again, see if it's performing to the same or better or worse. And it also allows you to, on these time conditions, try and catch transient problems that occur. So a few options there. So this isn't actually in the product yet. This is one of the reasons that I'm running one of the developer builds. It's due to come out. It's working its way through validation, I believe, at the moment. But as you can see, it's actually in quite an advanced stage. Again, not something that necessarily end users are going to get involved in. I think this is much more likely to be OEM system integrators who are doing code development, and it really does certainly assist our developers in-house as well. So, let me have a look and see. Whew. Trace for your application. Okay. So, again, we're now moving out of the source debugger. I guess some of you will be glad. I did tell you it was quite a big application. It is the one that we use the most, certainly internally. RPC Diagnostic. So just a very brief explanation. I'm just going to kill that off to stop my processor cooking. RPC, Remote Procedure Call. RPC we use that a lot. What RPC essentially means in layman's terms is the data communication between VTScada servers. So if you've got two servers or a workstation and a server, it's the method by which we transfer the information between VTScada to VTScada. So as you know, when when a server pulls an I/O device and gets some data, it displays it on the screen. We also transfer that data to the other machines so that they know. And we call that RPC just colloquially. So we have some tools to look at how RPC is performing, and we'll look at that now. So again, another warning. I guess it's Schrodinger's cat. Anything you look at, if you observe the problems, you could potentially make it worse. So I would again urge caution running up RPC diagnostics. The reason for that is that the tracing of RPC to file is an expensive operation. It takes a lot of processing load, and it takes a lot of processing time, VTScada processing time. it can actually make the problem worse. So I'd just like you to take caution on that. So what we'll do here is run up, the application is called Trace Viewer, okay? Again, ships with VTScada, and it looks fairly innocuous. If you click on the lightning bolt icon, top left-hand corner, you get a list of things that can be traced. So the information that we can trace using this tool are SOAP message tracing, for anybody doing SOAP interfaces, XML data handoff to other systems. RPC Diagnostics, that's the one that we're going to be looking at. Historian Diagnostics for advanced diagnostics. And then driver tracing, so you can actually trace the communications drivers using this utility and get the communications data. So the one we're going to look at is RPC Diagnostics just now. So I'm going to enable both of those, and you see a window full of data there. Mostly meaningless, even to most of the developers actually. It does have some meaning, obviously. It details what's going on between the two servers, but we typically don't look at this level. The RPC subsystem is fundamental to VTScada. It's been in its current incantation since 2001, and it's fairly rock solid. So they typically don't have to look at the data that's in here, but there are some other tools that are exceptionally handy. And especially for folks installing. So, sorry, let me just pause. So I'm going to pause the data there. That just stops it from updating the screen, saving the disk, so on. And we're going to click on these icons up here. So there are two that are of interest to me here. There are RPC Diagnostics sockets, and there's RPC Diagnostics services. So having a look at the sockets, first of all, pops open its own window, and what this is doing is giving you a view into VTScada's view of the world, and you can see that there are 3 machines that my laptop knows about. It knows about itself, it knows about KDNB VM, the virtual machine that I'm running here, and it knows about something called another server, which doesn't actually exist. But I added it to show that that window matches the server lists that you configure for your application here. So you can see my server list has 3 machines it knows about. If you're running on a network and you have multiple machines, it will show 1 entry in that window for every machine. In here, you can see sort of blob. It's red and green. Red indicates that it's not currently connected. So we're not connected to another server because it doesn't exist. But I am connected to my virtual machine, and I am connected to myself. We can actually send RPCs back to the main server, doing a broadcast where we distribute the RPCs. You can also see that there's a local and a remote. So local means that this is actually this local machine, and remote is it's a remote workstation of some description. And then queue length. So the queue length is the RPC queue, and this is where a lot of customers have been caught out on this. RPC works by having a queue built in to the machine, the local machine here, for each server that it's communicating to. So what we're looking at is the view from this computer, very, very specifically. And the queue length is 0. We're actually processing the RPC queue at the moment so quickly that you can't see that queue increment. However, if you had a network that was faulty, or you had some problem on the network, you can see that queue start to increment and back up. And that's a problem. And this is where you can tell the status of your network. There are some diagnostics. As you expand each of these, you can see here different socket connections. So I've actually got 2 socket connections open to the VM. at the moment for whatever reason. I guess it's doing, and you can see that there's TX, RX, there's pings. So we have background pings to keep the RPC alive, make sure the machine's still there, make sure it notes what's going on. And then the one that's quite interesting is disconnections. So you can see quite a high number of disconnections. That's an internal number. That's just noting the number of times that service link has dropped. So if that's a high number, you sometimes want to have a look and see what's going on in your system, because it should be consistent and it should be fairly low. Don't want to say too much more other than it does give you quite a good view into, especially on a larger network. So we have the biggest network system that I manage in the UK has about 45 clients and 2 servers. So keeping an eye on that whole network is kind of onerous, but it's really simple with that tool there. The second window here is kind of neat as well. Again, let me see, I can't actually expand it, unfortunately. What that window shows there is all the services that are running in VTScada. So a service is really just a piece of code that is running there to deal with a particular thing. To give you some examples, we've got a time synchronization service, and we've got a modem manager service. And when we create a driver, you can see we've got the Modbus simulator driver. That's the driver instance that was running. And again, this ties up to your server lists that you configure in the application manager. So when you go on to the advanced section, you can start load balancing by assigning different services to different servers. It's not very common to do that, but it is absolutely possible. So what this does is this shows us which machine is the server. So you can see that KDNB is the server for all services on this machine at the moment. If I just expand one, so I'll use the Modbus driver here and expand. You can see that another server is in the state pending. That's because another server doesn't exist. It's never connected in, it hasn't synchronized, it hasn't got the data for the Modbus driver, so it's not able to display any data. But you can see that my virtual machine is running there, and it's all synchronized and all good. So it's connected. It's not in client mode, it's in potential server mode. It is synced. The service is fully synced. It's not running in what we call alternate mode. And to touch on that, if you have a bad quality data connection to your device, you can configure the drivers to fail over to a backup server, even though all other services on that server are working fine. So if you've got a connection physically from machine A to the end device that's broken, it can fail over to machine B, but only that service. And that's called alternate, and we're not running in that mode at present. So to try and demonstrate this, I've got my VM. I'll just bring up Trace Viewer on here and show you the state of the world from this perspective. So it's a different perspective on the same network. So here we go. Pause that, bring up the services list. So here you can see that there are some services that actually are running on this machine. So the VIC manager, for example, for managing connection clients to my virtual machine. But for the most part, KDNB is the server for all those. And popping open the drop list will show you the different connections again from this machine back to the main server. If I go ahead and stop this application, so to be clear, I'm stopping this on my notebook, not in the virtual machine. What will happen, live demos, is that the virtual machine is now taken over servership for everything but this strange GUID that's there, and that's part of the VTScada underlying, so we don't get involved in that. So you can immediately see exactly what's happening, the server status, which machine is in charge for any particular service across the network. Right, on a similar note, there is, and that's all I'm really going to touch on the RPC Diagnostics application. On a similar note, there is sorry, I should also point out, when you quit RPC Diagnostics, you have the opportunity to keep logging those to disk in the background. Again, caution, it is an expensive operation and it does take quite a lot of disk space. On a busy system, there's a lot of chatter in the VTS backbone, so you have to be very, very cautious. So I'm not going to continue logging. I'm going to say no, and that'll just quit that application. There's a application that ships with VTScada, but you probably haven't seen it. You need to add it into the application manager manually if you want to use it. And it's called RPC Timings. And again, a little script utility, kind of handy for bigger networks. But it's nice and simple, almost self-explanatory. There's a little play icon in the top left. If I click that, what that does is goes off and finds out the timing between all the computers on your network that VTScada is aware of and is connected to. Now, I guess I'm missing some diagnostics here, probably because I'm not running the application. I know it came back, so we've got an RPC queue delay, which is quite interesting. So this is almost likely a dead socket connection that has been failed, automatically restarted in the background. So VTScada is taking care of it for us. We don't need to know why or how it happened, it's just done it in the background. But you can see here it's not particularly useful because I only have 2 machines, but it's showing me the IP address of my virtual machine. And be aware that the IP address may not be the IP address that you think it's going to be. VTScada, when it starts, will query all interfaces that are on that machine. And it knows about all those interfaces, and it has socket listeners on them all listening for VTScada connections. So you can have redundant failover backbone connections between VTScada systems. So it may not be the IP address that you're expecting. And then you've got the queue delay. So that queue delay that you see there, the top one, which is our active socket connection, is 11 milliseconds. What that means is it's taking 11 milliseconds from the point that VTScada wants to send a message to the remote machine to the point that it is actually processed and sent. Okay? It's not the view from the other machine. This is all local to VTScada. Again, if you're seeing a large number there, that means that you've got a very, very busy system. It could point to a fault in code where you're generating too many RPC messages to flooding the queues over to the second server. Then we've got some timings, so average, best, worst case conditions, and finally the tolerance. And the tolerance is a value that comes from setup.ini, so that's the configuration file in the main VTScada folder. Again, not used greatly these days, but it was when we were running on WAN connections, and you might have had a DSL or a broadband connection or even a dial-up connection, and it would be have slow throughput. So you could actually put a bigger tolerance on that link, and it would have longer delays waiting for data to come through. So you can actually tune the network of the VTScada backbone, but these days we tend not to see too many instances of people using that. Okay, so I realize that I'm coming towards the end of my time. Let me just see what I haven't covered. So RPC timing is there. So we'll just very briefly touch on one other application. Where are we? Trace VTS actions. Again, I don't believe it's added to the VAM by default. It's there. If you run it up, this is really an internal diagnostic tool. So we log lots of information to that to that file. Now, again, probably not too meaningful for you guys as users and developers, but internally for our developers, when trying to diagnose a real difficult problem, there can be some really good clues in here. So what happens is you can click the Start to Trace button, and you can tick which particular services or bits that you're interested in logging to the file, and this will start tracing to a file in your VTScada directory, and it's vtstrace.txt. And if you are experiencing a problem on a dual system and you're collecting diagnostics to put into our support team, it's really important that you grab trace files from both ends of the machine. It gives a very, very good clue as to what could potentially be going wrong. There is also a VTStrace_all.txt file, which is always generated as well, and that has all of the options turned on in the background. So it's a good idea if you suspect an RPC problem, for example, just turn off all the options except the RPC, and then you'll have the one trace file without all the noise in the background, and you've got the VTStrace_all file, which has all of the logging in there. A couple of options just to record the number of records you want to keep held in RAM, and also a parameter byte limit. Some of these systems have really long parameters, so it's just to save filling up the file with unnecessary information. Right, so just coming to the end here, I don't think I wanted to say anything more on that trace actions. So things if you're experiencing problems with your system and you're looking to get technical support from Trihedral, internally we have a form that we fill out online to track your particular issue or incident, and there's a bunch of information that we need from you. Typically operating system, which OS are you running on, which version of VTScada are you running, how much RAM do you have in the machine. If at all possible, you're able to get a crash dump of the fault in progress. That's ideal, because get that dump file to us, we can actually then see what you're seeing at that exact time. If you're able to reproduce it, small change set showing us how to reproduce the fault, always grateful. And we have the FTP site, which you can upload all these files to. Put a password on zip files or whatever if you like to keep them secure, and that will allow us to help you solve the problems that you're having. Thank you.